Hello, I'm Dave from Learning Lounge.
And I'm Joe from Robinson Trianing.
Whichever one of our channels you're watching this on, you'll find the link to the others in the video description.
In this video collaboration, we're looking to see if there's any wiggle room in the 18th edition of the regs in order to avoid using RCDs for additional protection against electric shock. So this could be, for example, where a particular item of current using equipment such as a fridge freezer should remain on when the rest of the socket outlets are disconnected from the supply under fault conditions.
So we're talking about an RCD with a rated residual current not exceeding 30 milliamps. These devices have been commonly used in split load boards to protect a number of circuits, or of course you can find them integrated into a socket outlet.
Now, if a split load solution doesn't suit the design, it is possible to protect individual circuits by the use of RCBOs, which combine the function of an RCD and an overcurrent circuit breaker into just one device. Now, these are a slightly more expensive solution, but they save a couple of ways in the board, and they really help to minimise inconvenience in the event of a fault, as only one circuit will disconnect instead of many.
Over the years, it's fair to say that we've seen the requirements for RCDs grow in number. For example, with the introduction of the 18th edition, there's now a requirement within domestic, that's household premises, for additional protection to be provided for AC final circuits supplying luminaires. Additional protection is also now required for socket outlets with a rated current not exceeding 32 amps, and that's up from the not exceeding 20 amps in the 17th edition. So all socket outlets that are installed in a domestic premises will require RCD protection. And with the 18th edition, you can't even use a label to identify the socket for use by one item of equipment, as that reg has now gone.
So with these latest changes then, generally speaking, we're looking at commercial and industrial installations as locations where it's possible to avoid using an RCD. One solution would be to carry out a risk assessment, which must be both written and signed by a responsible person, possibly the building or the business owner. But unfortunately, this is not an acceptable solution for domestic premises.
In fact, the only circuit supplying socket outlets that would not require an RCD would be one supplying socket outlets rated above 32 amps, so unlikely in a domestic setting. And concealed wiring would have to be suitably protected using the method specified in section 522.
And let's be honest, very few people are going to want to run circuits in steel conduit or trunking in a house, but don't forget you could still encounter steel conduit in older flats or similar dwellings.
So we're seeing in a domestic installation, every circuit and socket outlet will most likely require RCD protection. It's more likely going to be in commercial or industrial installations where there are alternative solutions that allow the designer to not specify the use of RCDs for additional protection.
That's right, Dave. The use of rugged wiring systems to provide mechanical protection are the norm here. So concealed cables using this approach are unlikely to require additional protection, and unlike dwellings, there's no need for circuits supplying luminaires to be RCD protected. So unless a socket outlet is rated over 32 amps then, it will still require RCD protection, either at the socket outlet itself or at the origin of the circuit that supplies it, especially where the wiring system is concealed and does not incorporate an earth metallic screen or isn't suitably protected against mechanical damage.
Let's now consider risk assessment, which is another method that can be used to determine whether the use of an RCD can be avoided.
Now, this is one of those areas of the regs that feels a little bit ambiguous, especially as there's no examples given in there. It's therefore quite a heavy responsibility to make the judgment call not to install an RCD, because it's a decision that could ultimately result in injury or even death.
Risk assessments, as covered in the Management of Health and Safety at Work regulations, can be a very involved topic. Stripping it down for our purposes today, we're really comparing the consequences of having or not having RCD protection. Now, having an RCD is a good thing, as it will save an individual's life. But if its operation was to cause a loss of power that put more lives at risk, it could be argued that it would be better not to have it. An example might be the supply to an electromagnet on an overhead crane, if it were to disconnect and drop tons of metal on a group of people below. So in this case, you would carry out a risk assessment to weigh the risk for each argument and consider measures to reduce the risk to everyone that could be injured.
Another basis for a risk assessment, but one where it can start to feel quite uncomfortable, is in industrial installations where there may be massive financial implications if supplies were to fail, possibly causing damage to critical process equipment. The financial argument, though, is an uncomfortable one because you're asking how can you put a value on human life? But there are other aspects to risk assessment as well.
Yes, the likelihood or probability of an incident is also taken into account. One way of reducing the risk might be the decision not to provide RCD protection. It comes down to good circuit design for me. If you have a circuit where losing the supply is going to be a major problem, then perhaps you need to think about other measures rather than not having an RCD. If you're that bothered about losing supplies, perhaps consider a backup power supply such as a UPS.
Now, in an ideal world, it would be great if we could just give you a list of examples where a risk assessment could be used to, without any doubt, exclude the use of an RCD. But unfortunately, the real world just doesn't work like that. Every installation, every application is different. Also, we've got to think about the type of people who use the installation may also differ. Are they, for example, skilled, instructed, or ordinary persons? Or perhaps we're talking about a school where kids might be inclined to stick things into socket outlets.
So there we are. We've seen that the regs really do want us to install RCDs wherever we can, as they're great at providing additional protection against electric shock and so improve safety. We've also seen that although there are considerations for not using them, our options under the 18th edition are increasingly limited.
We've seen that in domestic installations, unless it's for a socket outlet rated over 32 amps, then there's really not much room for wiggle. But in an industrial or commercial installation, there may be some options. However, you may want to think about taking a brave pill if you're going to go down the risk assessment route.
But if you do go down that route, you have to remember that failing to provide additional protection by RCD could put someone's life at risk in the future. Thanks for joining us for this collaboration. It's goodbye from me.
And it's goodbye from him.
See you soon.